This is pure maths 2 from 2019, just regular A-level maths, just get to it. So we need to turn all these into powers of 2 maybe, so that's just a 2 squared here. I'm also going to deal with this, the 2 to the 1 and 2 to the half here, which of course added makes 2 to the 3 over 2. Here, this multiplied makes 2 to the 2y. And now because these are multiplying with the same base, I can say this is 2 to the power x plus 2y. This is 1 over this, so I can just put a minus in here. And then we can just set that this is equal to this, and we'll have our answer fairly quickly when we just do some rearranging. Alternatively, you don't even have to deal with this, right? As long as you do the same thing over here and get to like this point, you can just have that equal to the original thing, and you can just take log of base 2 both sides, and the calculator will give you the 3 over the minus 3 over 2 that you need here, and then everything from there will be the same. Question 2 then, so we have something going on at time and then some speed here. Now, if you imagine this as a graph with time on the x-axis and speed on the y-axis, that's a speed time graph, and the area underneath the speed time graph is the distance, which will therefore be the length of the runway. So if we imagine this as a graph, we're going to work out the area underneath it, which of course just means doing trapezium rule, which is in the formula book. So h is 25 minus 0 divided by 1, 2, 3, 4, 5 shapes will be made here between this, 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 and this. So h is 25 minus 0 over 5, which is 5. And then we can just put everything in the formula. This and this are y0 and yn. And then these ones in the middle here are the ones that get times by 2. And we get this answer to finish. Given that it accelerated smoothly, so that means its speed was going upwards and upwards and upwards, kind of like this. If you're putting trapeziums underneath it, then those trapeziums will overestimate, and so the answer will be overestimate. Just maybe draw a picture to do your explanation. Here then, this formula here only works for radians. Of course, it doesn't work for degrees, which is what we've been given. So you could either convert this to radians, or you could just use the formula you learnt in year 8 for degrees, pi r squared times theta over 360, and you'll get your answer. It doesn't really matter how you do it, but whatever. This is kind of an interesting question. So we're looking for the intersection of this circle, which is C2, and this kind of oval, which is given parametrically. You could actually just put this x value in there and this y value in there to sort of set them equal to each other, kind of thing. And we'll just solve for a t. So of course, if we square these out, we get this. 4 squared is 16, root 2 squared is 2, so you times this together. You can break this up into 100 lots of cos squared is the same as, 58, 68 of them, and another 32 of them. I think those two things add up to 100. Yeah, sure. So of course, factorize out the 32 from here, and then these two things add up to make 1 every time. So that just gets to 32. Take away 32 from both sides, divide by 2. Square roots to get either plus root 1 over 2 or minus root 1 over 2. You might know your exact values here. If you don't, your calculator will tell you that t is this or t is that. Now get out the cos graph, because there are 4 intersections here. So what that probably means is there are 4 t solutions to this, each one of which, when you put in here, will give you each one of the 4 solutions. So the cos graph, root 1 over 2 is like 0.7. So that's up here somewhere. Your calculator is giving you this solution at pi over 4. So the other one is, of course, 2 pi minus pi over 4, which is 7 pi over 4. And likewise down here, so 3 pi over 4 is one solution. Just do 2 pi minus that to find the other one, and we get this here. And now, which of these 4 solutions, when we put it in here, is going to give us this specific one? Well, if you're not sure, just try them all and look for one positive. You want a positive x value, right? Because you want to be over here, and a negative y. And only one of these will give you a positive x and a negative y. If you don't want to do it like that, what you can just think is you're in the 4th quadrant, so you want sine to be, in this quadrant down here, you want this to be negative and you want this to be positive. If you've done cast diagrams, you know that cos is positive and sine is negative in the last quadrant. So we want to be the last solution here. So this one's going to be the one that works, which is this one. So if you put those in, we'll get our 2 answers. And you can, of course, check those by substituting them back in. But in any case, trying all of them would have also worked as a strategy. This literally just means the integral of this between 4 and 9. That's what integration is. It's the sum of a load of rectangles as those rectangles get smaller and smaller. So they're just asking us to integrate this. I'm not going to go through it very carefully because I think it's quite easy as long as you just know that if you see anything that looks like this, you're just being asked to integrate. Here, so we've got a piecewise function. G behaves like this up to there, so it's a quadratic up to there, and then it's just a straight line beyond that point. Find g of 0, so let's find g of 0 first. G of 0 means using this rule, because this is less than 2. So put 0 into here, we get 5. And then put g of 0 is just g of 5, because g of 0 is 5. And then g of 5 follows this rule, so you just put it in there and we get 13. Find the values for which this happens. So let's do this separately. So let's say first, let's just consider this and see if it happens here. Okay, let's just say this needs to be greater than 28. take away 1 square root. Now, if you're square rooting this, because of this inequality, it's a little bit more complicated. Anything bigger than root 27 would obviously work. Like root 30 squared is 30, which is bigger than 27. But also anything less than minus root 27, because like minus root 30 squared is positive 30, which is bigger as well. So just be a bit careful there. Add 2 to both sides. And now only this one matters. Sorry, only this one matters, because here we're only considering, this graph only exists if x is less than or equal to 2 as it is, and this is bigger than 2, so this just doesn't matter. This is less than 2, so it's quite a lot less than 2, isn't it? Because that's about 5. It's less than minus 3, roughly. So this is the one that matters. We'll leave it there. And then we'll just do the same thing for this one here. So if x is greater than 2, let's see when this is greater than 28. This is much easier, of course. And this is bigger than 2, so the initial condition is met here. So it's just going to be this and that as our two solutions. H is defined by this. So H is essentially the same as G, but it goes up to here and then just vanishes because there's nothing after that. H has an inverse, but G does not. G doesn't have an inverse because it's a one-to-many function. Sorry, a many-to-one function. There are essentially many x values that get the same single y value. So, for example, here you get to a y value of this, which is the same as if you input this x value here, you get to the same y value. Whereas H doesn't do that. There's only one. It's a one-to-one. There's one x value gives you one y value, and those are the functions that have inverses. So that's just, I guess, something you just needed to know about that. Maybe I'll put a video in the description talking more about that. Anyway, solve the equation this. So just, you know, when you're solving for like sine and cos equals a number, you can just move the sign to the other side and use the -1. You can do the same thing with this. You can just move the h to the other side and ignore the -1. So like functions, you can just swap the side of as long as you just do to the -1 or not to the -1 or vice versa. So this just means x equals h of -1/2, and we can just put -1/2 in there and we'll solve for x very quickly and we'll get our answer. 7 then I thought was a weirdly hard question, particularly for this part of the paper and particularly for not being worth very many marks. So initially it starts off very easy. Y is modeled to be a fixed cost, so y equals just some number n plus some constant times the number of bars made that day, which they've already said is x. So that's fairly straightforward. This is not as easy, just because it's very easy to just not get this set up right. The bars are sold for £2 each. So initially when you look at this, you just think, oh, okay, so y is 500 when x is 800, and I'll just solve for n and k by using these two things here. But y isn't the profit, y is the cost of doing this. So what you first have to do is you first have to say that the profit is going to be equal to 2x, 2 times the number of bars you make, minus the costs, which are y. And of course we can rearrange this to make y as this. And then what I did was I put this equal to that, and then put in these figures here. So I said profit is 500 here, and x is 800, and then profit is, I can tidy that up, I guess, and then profit is minus 80, just read this carefully, and x is 300, and we'll get this, and then of course we can just do this minus this, and we can solve for both these things. We can put it back in to find n as well. But yeah, just kind of depicking this whole profit and costings thing to make this made it a bit more complicated, but eventually you get the right thing, and you'll end up with this here. 0.4 is the, or 0.84, sorry, is the cost per thing that you make. Oh, and then, yeah, of course, so you need to show this. So I've shown n and k are these things. So my initial setup is this, but of course this is y, based on my definition earlier from here. Profit is the amount that you make minus the costing. So yeah, this goes back into a y and you get what they wanted you to get. Yeah, so 0.84 is the cost of making each bar, which you already knew because that was just the k value we defined as being the cost proportional to the number of bars that are sold per thing. So if x was 1, this is the cost of making 1 bar. Find the least number of bars of soap that would need to be made to make a profit. You can just use this formula here, actually, I think, is the easiest thing to do. No, in fact, even just this formula here, right? So where y is given as what we found here, because then we can just simplify the x's, and we can just say, okay, well, we need the profit to be greater than 0, so we need this to be greater than 0, and then we can just solve for x, and we get x as this. Just do a quick logic check. This seems legit, because when it was 300, we made a loss, so being bigger than 370 seems like a pretty reasonable thing to say. Good, here, so we've got a sequence here. The first time when you use r is 4 is 20 times a quarter to the power 4, which is this, and then 20 times a half to the power 4, and then a half to the power 5. The first time is 1.25, so that'll be our a here, And of course, you times by an extra half each time, so that's going to be 1 minus a half on the bottom there. And we can just type that into calculator and get this. Show this thing here, so use log laws, do this, log 5 of this minus log 5 of that, just splitting them up. This feels a bit like an FP1 thing, I think, or FP2 thing called recurrence relations, but it's not that tricky. Just put in n as 1, and you get this. So that's the first term, when you put in n as 1 to both these things. Then put in n as 2, and you get this. And then put in n as 3, and you get this. And what you might notice is that this cancels with that, and this cancels with that, and so on and so on. The last term, by the way, when you put in n is 48, will be this. But every single thing here will cancel, except for this log 2, which has nothing to cancel with, this minus log 2. And also this log 50, because it's the biggest one, it also has nothing to cancel with. So you're just left with log 50 minus log 2. Of course, you can do 50 divided by 2 here, which makes 25, and then 5 to the power 2 is 25, so the answer is 2. Question 9 then, so we're turning this graph into this one. Show that we can model based on this graph. So we're just looking at this graph here, figure 6, but show that we can model it with this. Well, this is a straight line, right? So straight lines are y equals mx plus c, but y is this, and x is this. So we have log to base 10 of d equals sum m times this plus c, except we already know what the y-intercept is as this, so I can put that in straight away. I've called this a just because I did, I don't know why. But this is just y equals mx plus c, where c is that, and y and x are these two things. And now, of course, I can raise both sides to the power 10, or I can first move this a up to here following that log law, then raise both sides to the power 10. Remember, when you raise both sides to a power, or do a number to the power of both sides, I guess, whatever, to clear out this log 10, you need to do it to the whole thing. So this is all in one power here. And then, of course, this is minus this, so we can sort of treat this as times by 10 to the minus this, because when you've got two bases the same and you're timesing with some powers here, you would add those up to make this. But this is just this number actually here that they wanted, and this 10 cancels this log 10, and you just end up with this here, which will be our answer to this question, I think. And yeah, just move this to the front, I guess, and you get roughly what they wanted you to get. Use this information to find a complete model for this based on this here. This literally tells you that when d is 20, because that's the y, when d is 20, v is 30. So just put that in here. Just put 20 and 30 in there. Divide by 0.017, take log of base 30 both sides, and we get a as this. And so the complete model is this here, with a as that value there. Sean is driving at 60 miles an hour and notices something 100 meters ahead. It takes him that long to do before applying brakes. So he's traveling at 60, which is v. So the distance it will take him to stop is just putting v as 60 into there. So we'll do that. However, there's more to do here because it takes him this long before he applies the brakes. So what we need to figure out is how far he travels in this small time window. Now, speed is distance over time, so speed times time is distance. We have a speed here, we have a time here, except the units are all wrong. So let's divide this by 60 to get it into minutes, and then divide it by 60 again to get it into hours. And then let's times this by 1,000 to make it meters per hour. And then our distance will be in meters, because this is meters per hour, and this is in hours, and we'll end up with this. And if we add those two things together, we'll get something less than 100. So yes, he will stop in time. Question 10 then is about this triangle, some vectors here. So let's apply everything on this. C is, so the point is OC is double OA. OA is here, so double that is up here somewhere. So C is up there. Now M is the midpoint of AB, so that's in the middle of AB, somewhere there. Straight line through C and M goes down to the point N, which is down here. OA we're defining as A, and then that also means this is A, of course, and then OB is B. Good, C to M then. C to M from here to here. We could just do, I guess, firstly, we could work out A to B is minus A plus B, because these are going this way and this way. So minus A plus B is A to B. Half that, because M's in the middle, is minus a half A plus a half B. And then, of course, we can just say C to M is minus A plus what we just worked out, which ends up being that there. Show O to N is this thing here. So O to N is this across here. What we could do is we could do O to C plus C to N. Is I think what I did here. Now O to C is just 2A, obviously. C to N is some multiple of C to M, because they're on the same line, right? It's just a larger version of C to M. So if I just do 2A plus some amount of this, I should get from C to N. I'll call that some amount lambda. And now, of course, I can just group up the A's and the B's, and I end up with, I think, exactly what they wanted me to get, it looks like. Hence prove ON to NB is 2 to 1. Now, what do we notice about ON? Well, it's just traveling on this horizontal line here, which means its vector is just of the form KB. right? It's just some multiple of b. So the a part of it doesn't exist. So therefore, on actually, if we've got this expression here, lambda needs to make it such that this is 0 because it's traveling parallel to b. So this is just 0 here, so we can solve for lambda is this, and then we can put that lambda back into here to actually work out what on is. So half times this is just 2/3, so we get on is this. So this here is 2/3 b, this whole thing is b, so that means this is 1/3 b. So we have 2/3 b to 1/3 b, that's a ratio of 2 to 1 as required. 11 then, so a really interesting derivative here to do, y equals x to the power x. So let's take log to both sides. Now I realize I did a maths degree, so when I write log and say log, I mean log to base e, because that's just the correct way to write log to base e. I realize A-level maths thinks differently about that because it's wrong, but I just typed this up and then realized later on it actually mattered, and I couldn't be bothered to change it. So I'm just telling you now this means log to base e, which it always means, because by default when you're watching R2G2, if I just write log, I mean log to base e. But yeah, just saying that. Anyway, let's take a log of both sides, then derive both sides here. Now to derive this, the derivative of a log is just 1 over y, but I've derived the wrong thing, right? I want to derive both sides with respect to x. So implicit differentiation says just do 1 over y, because that's the derivative of this, and then just times it by dy by dx. I also put the x to the front here following log laws before I derived, because now I can use product rule on here and derive that one for 1, leave that one alone, and then leave that one alone and derive that for 1 over x, and you get this, times both sides by y. This cancels obviously to a 1, which is nice. And then y itself is just x to the power x, so you can replace those in there and you get this here. Now we want to know the turning point of c, so we want to know dy by dx equals 0. So let's set this equal to 0. We can factorize out the x to the power x, and now this is an exponential. It's a weird exponential, but it is just an exponential, and exponentials can't equal 0. So that means this thing here is 0. Take the minus 1 over, and then raise both sides to the power e, I guess, or e to the power both sides, I should say. And this is where the log, this is the fact that this is log to base e matters, right? And we get x as this as our answer. And that's, I think, all they wanted us to get. Show that alpha is between this, if this is here. So if alpha was 1.5, so if x was 1.5, we would get y is this. And if x was 1.6, we would get y is this. And because 1 is less than 2 and 1 is bigger than 2, that means alpha must be between those two results. Just saying something like that will work. And then some iterations to do at the end here. So x1 is this, so let's do x2. So if n is 0 here, sorry, if n is 1 here, we get x2 equals 2x1 to the power 1 minus x1. x1 is 1.5, so we'll get this. You can type that in the calculator, you get this. To find x4, we just need to replace the thing in the calculator with that and press equals once to get x3, then press equals twice to get x4. This is interesting long-term behavior here. If you just keep slamming the equals button on your calculator, these numbers get further and further apart until your calculator will just give you 1, 2, 1, 2, 1, 2. So you kind of diverge to 2 points which you oscillate between, and you just need to say that's what you're looking at, and that's what you have to do. Good. Prove this thing here. So this is a hard spot, but first it feels quite natural to try and put these fractions together. So times this one by cos over cos, and this one by sine over sine, and we get this. Now we can put these numerators together because the denominator is the same. And again, this is quite a hard spot. It's very tempting to try and deal with the cos 3 theta and the sine 3 theta. If you look really hard at this thing here in the formula book, though, this here looks a lot like the thing that you've just put on the top of the fraction, right? Cos, cos, sine, sine. So actually, if you just replace a with 3 theta and b with theta, I think you get exactly this. And then this is a plus here, which means we want a minus here. And I think this top section here just equals cos of 3 theta minus theta. I'm just using this rule backwards, right? Imagine applying this rule to this here, right? We'd get cos of, so a is 3 theta, so this would be a 3 theta, and then b would be a theta, and then you've got a minus in here, so we use a plus here, and then 3 theta and then theta, and that's exactly what you get here. All right, so just applying that rule backwards, quite a difficult spot. Anyway, from here, of course, that's cos of 2 theta, and then you might know the rule, and you probably should, that 2 sine theta cos theta is equal to sine 2 theta. So therefore, sine theta cos theta is a half sine 2 theta. I probably should have written that rule down. But again, it's just using this rule here, right? It is just using that rule there, where if you set a equal to b, you get sine 2 theta, or sine 2a, whatever, is sine a cos a plus cos a sine a, which is just 2 sine a, and then half both sides, and you get this eventually. And then cos over sine is cot, keep the 2 theta the same, and 1 divided by half is 2, which is the right-hand side. Then, of course, we just replace all of this with 2 cots 2 theta, divide both sides by 2. This is 1 over tan 2 theta, so just flip this over to be a 1/2 to get a tan here. Do tan inverse, you get this. And now tan is repetitive every 180, so just add 180 onto that. We're in degrees here. And then when you divide by 2, this is going to be the one that's between these 2 points here. So I'll just take this one and divide it by 2, and I'll kind of just ignore the other one because I don't need it. So yeah, that's good. Just a couple of questions left then. So the differentiation question here then. So we need the surface area, right? So surface area is this circle here, which is pi r squared, plus the curved surface of this cylinder, which is 2 pi r all the way around that side, times h, because you can unfold it into a massive rectangle. So 2 pi r times h, and then these, it actually gave you the formulas, I cut them out. But it said that the surface area of a sphere was 4 pi r squared, so therefore the surface area of half a sphere is 2 pi r squared. Okay, so that's not enough information quite yet to do this, but it also tells us the volume is 6. So the volume is pi r squared times h, which is just the base of this prism times the height. And then it also gave you that this volume of a sphere was 4/3 pi r cubed, half that for 2/3 pi r cubed. Now, of course, I can rearrange this for h by taking this away from both sides. I also know that v is 6, and then rearrange for h, and then actually, what I actually did here, rather than rearranging for h, is I just divided everything by r to get this. And the reason I did that is because this can then just slot perfectly into there once doubled. Of course, this plus this is just 3 pi r squared, and then this just slots into there and gets times by 2. And that was the easiest way to do it, I think. And then 2 times this is 12 over r, which is good, and then 2 times this is 4/3. 3 minus 4/3, I think, is 5/3, if I'm not mistaken. And we'll get this here, which is good. That's what they wanted us to get. Use calculators to find the place where it's a minimum. So let's do dSA by dt. We get, sorry, by dr, of course. 2 times this is 10/3. Lower that down. Minus 1 times this down to here. You get to a minus 2. Let's set this to 0 because we're looking for a minimum point. And we can times everything by r squared. 0 times r squared is still 0. R times r squared is r to the 3, and that gets rid of this r to the minus 2. Put 12 over here. Times by 3, which is 36. Divide by 10 is 3.6. Divide by pi, and then cube root, and you get r as this. Now, I don't think there's any work required to actually just demonstrate that this is a minimum. You might want to play it safe if you've got a spare 2 minutes in the exam and differentiate this again and put this r value in there and show that it's greater than 0 and therefore a minimum. I think we can argue that it is just a minimum based on the fact that they've told us that it's a minimum and the fact that this is the only solution, I think, to this equation. Or maybe it's not. But anyway, the mark scheme said you didn't have to do it. So maybe play it safe and do it anyway. But the mark scheme said you didn't have to. You could also count the marks here and come to a conclusion yourself as to whether or not you think 4 marks requires you to actually do that as well. And maybe hedge your bets a little bit. Anyway, calculate the minimum surface area. I mean, we literally just put this number into here. And yeah, we had 2 marks. Anyway, the last question then, to the nearest integer, I guess, is 17. Last question then, use the substitution. So clearly this gets replaced with a u. What about the dh then? Now, the most obvious thing to do is just work out u by dh. I didn't. I actually just rearranged this and then squared both sides and figured finding dh by du would be much quicker. So bring this 2 down here, lower it down to a 1, and then the derivative of this is minus 1, so that's where that minus comes from. And now just times both sides by du, and I can get something that I can immediately replace with dh, rather than if you differentiated this with du by dh, you'd then have to do some fiddling to get it back in the right place. But this is, I think that was a slightly faster way of doing it. Anyway, so you get this thing here divided by u, and you're doing that integral. Of course, this is just 2u because of the 2 negatives, minus 8. You can integrate this by just splitting this in half there to make this, and then this is just 2, which integrates to 2u, and this is 8 over u, which integrates to log 8, sorry, 8 log u. And then we can just put the u's back, right? We can just put this u back into here and here, and we end up with this, which I think is what they, oh, it's almost what they wanted me to get. Expand this out, and this becomes an 8, which is just a constant. So you can just put it into that constant and make a different constant, and then we have, I think, what they wanted us to get. Find, according to the model, the range of heights of this species. Now, I feel like a lot of people would not picked up these 2 marks because you have to think it through a little bit. But essentially, this tree is just growing in height. So therefore, dh by dt, the rate of growth, has got to be positive because it's just growing, it's not shrinking. And so therefore, this whole thing has got to be greater than 0. But of course, this is an exponential, so it's always greater than 0. And this is just a number, so that means this needs to be greater than 0. And we can just move this over, square both sides, and we get h is less than 16. And of course, h has got to be greater than 0, I think, because it's a tree. So therefore, I think we have this as our answer. And then finally, according to the model, calculate the time the tree would take to grow this tall. So we need to solve this differential equation. So what we're going to do is we have our initial condition of 1 meter high when t is 0. So let's cross multiply here. So let's put this dt over here, put this object down here. Of course, we know if we apply some integrals to both these sides, we know the integral of this because we were asked to do it before, so it's all of that. The integral of this, just raise t up to the power t to the 1.25, divide this by 1.25, you get 1 over 25. And then apply this initial condition here. So when t is 0, this becomes a 0, so this all becomes a 0. When h is 1, you just get, this is a root 1 is 1, so this all becomes a 3. And you get this, so k is that. So now we can write down this as the general solution, I think, just replacing all these things here. And yeah, that's good. What we need to do, though, is work out how long it would take to reach a height of 12. So we need to put h is 12 into here. And then, yeah, all of this is a funky looking number. So just type it all into a calculator. Get this, times by 25. And then the easiest way to finish this off is to take the 1.25th root of this number here. Whatever number is here, you can just take that root in your calculator. And you'll get your answer of this, which is done. The paper is done. Fantastic. See you next time.